systems. Like let's see about the let's examine a real world case studies. Like we will dive deep into one selected case study. For example, let's see about the 3 practice, like how AI is implemented in actual engineering problems. Okay, let's discuss about the real world case studies today in our session. And then let's discuss about the challenges about it and trends about it. Finally, we all explore the challenges of implementing AI, and then let's search as a data issues like domain expertises or infrastructures and look at some current trends shaping the future of AI, like what we called generative AI and AI in IoT also, and then edge computing. All these are that. And this one, and by the end of the session, my goal is to reach the how AI is works through our life. Okay, and let's clear about understanding of AI and how AI can be integrated into our domains. And let's say explore the more details about the AI and how it will be implemented in our teaching or in our projects in our daily life. And next, let's we are already we are a lot of people are using here like a chat GPTs or any there are multiple AI tools are there like a image modifications or a PPT generations or PPT modifications or image modifications, audio generations, video generations, all these things. And then let's discuss about the introduction to AI artificial intelligence. Just let me share my screen. See here, introduction artificial intelligence means how the slide, like what we call the artificial intelligence means what is the artificial intelligence, how it is works to the people, that which language we are using for AI means AI does not has a single language. It is a combination of few technicals like it's what we call the artificial intelligence is the ability of missions stimulate human intelligence that includes like a learning from experience. First it will learn data and then it will predict or it will make the persons work, means it will make the missions to work, like for learning from experience or problem solving and understanding the languages and even making decisions based on the data. Okay, and like it is like a humans, it will make it like a mimic human thinking, and it will work more faster than the humans, and it can give you the more accurate and effective to the people. Okay, and then let's discuss about the history of AI. Let's see 1950s, the tuning test. See what it does it mean. Let's understand where we are today with AI. Okay, and then let's see in the proposed by legendary Alan Turing, the Turing test was the first serious question about missions, thinking like a humans. Okay, Turing asked today mission can ask missions to think like if a mission could respond like a conversation in a way from a human, it was considered as an intelligence, right? And then let's discuss about the 1956 Dartmouth workshop. This marks the official birth of AI, mean as a field. At this workshop, scientists like a John M.C. Marchett coined the term artificial intelligence and then laid down to the roadmap to build intelligent missions after that. Then coming to the 2010s, deep learning revolution. Deep learning revolution means this is when really took off, like with the rise of neural networks and GPU computing big data, AI application becomes more powerful enough to drive innovations. Like nowadays we are seeing in US, foreign countries, we have lot of self-driving cars are there. In our daily life, we are using face recognition or language translations, and every day we are using whenever we get a doubts or whenever we are confused. At that time, we are using chatbots. Lot of chatbots are there, many of which we are used daily today daily life. Clear, guys? Are you following me? Then next. And see why AI in engineering. Let's see about it, why it is and how it helps us. See, let's bring the focus to engineering. Why is AI important to in our engineering today? Let's see about the data explosion. Means with the sensors, IoT devices, and smart machines everywhere, we are generating huge amounts of data, like analyzing it and extract the value from the data and make the decisions better. Because whatever we are using, we are talking about machine learning or deep learning or artificial intelligence, it does not have any knowledge. Whatever we are giving the data, it learn from the data and it will generate the response from the data which it is learning. That's it. Clear? And then let's discuss about the automation and precision. Means AI allows us to automate. Means AI means what AI allows us to automate repetitive or complex tasks like defect detection in manufacturing or optimizing the energies in small grids or adjusting the parameters like a robotic arms like this. Okay. And with a high precision, like let's discuss about the decision making, how it enhances the decision making. Means AI provides the real-time insights from the data, like enabling the engineers and organizations to improve productivity and reduce waste and increase the safety. Like think predictive maintenance in mechanical systems or AI-based simulation in a civil engineering. Let's say about the you can think AI as a powerful assistant to the engineering, handling the massive data, suggesting solutions, or even predicting the failures before they occur. All these things. Like nowadays, we have policies. I think have any of you seen AI applications like a ChatGPTs, Google Maps, or AI-based diagnosis tools in hospitals? Like there are a lot of results, decades of AI evolution. Like in a specific branch, let's talk about in your specific branch, civil, mechanical, triple E, EC. You have seen a lot of examples where AI could help automate on enhance a task. Clear? So here, lot of them, for example, in medical industry also, a lot of people are using like they are diagnosis, some predictions, disease predictions. Whenever we are giving our details about it, like when I give the few inputs for it, it will predict whether the person has a disease or not, and it will predict which type of disease, which type of diagnosis is. So these type we are enhancing our decision making. Clear? And then let's discuss about the key domains of AI. Let's see about the what are the domains of it and what is AI and what are the crucial parts in AI. Let's see it. Okay, and this one and give you the it will give you strong grasp of the major fields of AI. Because AI is not only AI, it is a combination of topics. Let's see about that. Means let's say key domains of AI means first one will be the it will be AI means it will be the four domains we will focus on. Okay, and the first one will be the machine learning. Machine learning is at the heart of the AI. We will call it as because it is the ability to of missions to learn from the data without program for every task. Clear? Missions will predict the present or future from learning from the data. Clear? Example, if we train a model with thousands of images or a cracked bridges, it will eventually learn to detect structural damage automatically in a new bridge images. Like ML models get better over time as they see more data. This is called a model training and improvement. For example, I want to predict American Sign Language recently, which I have done. Sign Language means when people will give you sign it and it should predict it. Before going to do it, I need to train the data. I need to take a one algorithm for it, and I used to do the pre-processing steps, all these things. So the machine learning also it has a process, end-to-end process will be there. Like first we need to collect the data, and then we need to first of all we need to whatever we are getting the question from the customer, we need to analyze it. We have to think how we can do that, and then first we need to collect the data according to their requirement, according to the what we call according to the requirement. We need to collect the data and then pre-process that data. We need to analyze it and we need to choose a which is the best algorithm, which algorithm suits for that particular data and which gives you the most perfect accuracy, and accuracy will be depends upon your output. If you get the best accuracy, then your model is perfect. That means your model is perfect. And then let's discuss about the deep learning. Deep learning also works like a machine learning. This deep learning algorithms also learn from the data and predicts, but deep learning is a work on the complex data. Means, because why we call it as a complex data means it has more neural networks will be there. Like a deep learning is a subset of machine learning that uses the neural networks with many layers. Clear? That many layers we will call it as a deep neural networks. Those are the which we are using in Preston layers, multi-Preston layers. These all are will be there. Next, these deep learning algorithms, human, it will be inspired by the human brain. Like a deep learning excels handling the complex patterns, use huge data sets like a audio data sets, video data sets, or image data sets, all these. And then let's discuss about the example deep learning. So, for example, in our daily life, I'm using my mobile. Whenever I want to open my mobile, I need to give you a facial recognition or biometric. Means it will learn my facial recognition and it will learn the points of it. And then whenever it say my that unlock will be happen. Okay, not only facial recognition, as I have already told you, self-driving cars. Those are we will call it as a Tesla, which are using in foreign countries nowadays. Autonomous driving and voice assistance. Whatever we are giving the question, that will generate it. Okay, and these are the voice assistants. And 2010s and what we called in the 2010s advanced computing power like a GPUs, and these are the used to use because for doing a more for facial recognition or analyzing the patterns, all this we cannot use it. We cannot make it with a small data. It needs a big data. Clear? For that we need to use a GPUs. And then coming to the natural language processing. Natural language processing means this is the most important topic nowadays because most of the people are using the chat GPTs. Chat GPT means it is a learning from the text. It will give you the text. Whenever we are working on the text means it is a natural language processing, or we will call it as a large language models. Means NLP enables computer to understand, interpret, and generate human language intent. For example, it is used in like a chatbots. Chatbots means it is a chatbots means whatever we are giving the text or input to it, that input we will call it as a prompt. Whenever I give you a prompt, it will generate the response for it. Clear? And that one will be the and the next one will be the sentiment analysis. Sentiment analysis, whatever I'm giving the text to it, it will analyze what the sentence is, whether it is a positive sentence or negative sentence or neutral. For example, uh, e-commerce platforms will be there. E-commerce, for example, I have ordered some. For example, I have some ordered item. So for that item, lot of people will giving you the lot of reviews. At that time, in few reviews, they will give you the bad reviews and good reviews will be there. And at that time, we can analyze it using the sentiment analysis algorithms, using NLP algorithms. Like it will, whenever we are giving the product is good, means it is a positive sentence. The product color is good, not good. We are not satisfied we are not satisfied for that product. Means these are the positive reviews. Okay, it will predict whether the review is positive, negative, or neutral. Clear? And that will be the sentiment analysis. And then last one will be the language translation. Like we are using Google Translate, right? So that is from one language to it will translate to another language. This one. Okay. Whenever you type a sentence into a Google Translate, that will give you the meaning in another language. Okay, that will be also commented into the NLP action. And Next one will be the computer vision. Computer vision helps missions to see, means understand and process the visualization information. Like we do image recognition, object detection, video analysis. For example, whenever we go, the lift door will be open. That will be the object detection. And image recognition means it will forever. For example, Google Photos. In Google Photos, we will use multiple people will be there in our Photos app, but it will categorize what are the people will be like, it will separate the people, all the people photos will be in the one folder, and next one in for like it will categorize each folder having each person. Clear? And then let's see about the computer vision detecting defects on a manufacturing line, monitoring the traffic and inspecting buildings using drones, all these things. Okay. And next, for example, a self-driving car uses a computer vision to see the road. That's right, right? For without using that, it cannot. Because there is no driving for the driver for the self-driving cars. It should be the car that should be gone through like okay. And then deep learning to make private decisions, and NLP interact with the passengers like customer, like people users. Okay, and then let's see about the let's see. Let me share my slide. See, machine learning in engineering. Let's see about that. Machine learning, how machine learning is important to engineering and how it is perfect to the connect with AI directly into engineering problems. And how can you explain each part in a clear and let's see about. Okay. And then see about that. Like we have discussed what machine learning is. But now let's look at how it's applied in real engineering environments, like to drive innovation, efficiency, and reliability. Means machine learning techniques are transforming the way engineers analyzing the data and solve the problems and make decisions. Let's explore three, in this we will there will be three important aspects will be there, like ML engineering, for example, like a supervisor learning, unsupervised learning, and reinforcement learning. Supervisor learning means this is the where the model is trained using the labeled data. What is labeled data? What is unlabeled data means when we are before train the data, we know what the output is. For example, whether tomorrow will has chances to rain or not. Okay. For example, which has more chance? Means it has a yes or no, true or false, or how much price it will be. We know. For example, I want to predict the flight price prediction. Price will be my output. If we know the output, if we have the output in our data set, then it will be the supervised learning. When we do not have an output, it should that data sorry, algorithm should categorize which type of group it will be, then it will be the unsupervised learning. For example, where the model is trained using label data. Label data means predicting whether a mission will fail based on the historical sensor data with the labels like a fail, not a fail. Okay, come, not a come. Yes or no, true or false, like this. Analyzing. For example, as I have already explained you about the crop recommendation. In the first example, I think I have told you, crop recommendation means according to the requirement of the soil. What are the soil systems that in that particular field, which crop will be grow? So it will analyze it, whether it is suits for the rice or wheat or sugar cane. It will analyze. For that, we will call it as a supervised learning. Unsupervised learning means used when the data has no labels. Okay, it will discover the patterns or groupings. Example, based on the patterns, identify which behaving abnormally. For example, for the shopping one. Let's take any shopping mall. In shopping mall, lot of people will come. At the end of the year, the shopping mall owners will need to have a clear clear cutoff off for it. For example, see how many people are coming. For example, occasional customer target, and who are the people daily customer who spends more money in these. So they want to separate it. They want to groups for it. So those are the unsupervised learning. Clear? And next one, let's learn about the learning. Reinforcement learning means this is the most advanced in learning. The model learns the trial and by trialers, and it will give you the errors, and it will give you. Here we cannot call it as error. We will call it as a rewards or feedback. What we called it. So rewards are the it will give you the correct decisions. It will make you the correct decisions. For example, say robot learning, how it better over time by adjusting its speed and angle based on the performance feedback. For example, say lot of reinforcement which we are using for the mobile games. Okay, for chess game, where if we give it one step behind it, so it will give you a reward. It will give you the feedback. For example, for the Tesla cars also, in this type of games, we will use the reinforcement learning. And then next one will be the predictive maintenance. Predictive maintenance means this is the one of the most valuable like the real world applications of ML engineering. For example, see what we call the um, for example, say costly downtime, unnecessary. For example, here we for example, what we call missions might fail based on the sensor data. For example, we can predict exactly when a mission failed based on the sensor data, vibrations, temperature readings, according to that. For example, in a manufacturing or aerospace, predictive maintenance helps to avoid like a unexpected breakdowns. Nowadays, most of the situations are happening here. So costly downtime, unnecessary replacements. These are the ML models learn the warnings, signs of the failure, and alert the engineers in advance before happens something. It will give you the advance. It will give you the advance alerts for the engineers. Okay, and then let's see discuss about the energy load forecasting. Means another high impact area in optimizing the energy consumption. Next, using ML, engineering can forecast how much energy will be needed in the next hour or a next day or a next week. It will demand, and when the demand will be like this. For example, we need power grid management, like efficiently distributed electricity, reducing the waste and blackouts, renewable energy. All these things are commented into the energy load forecasting. These are the things. Clear? And let's give you the overall extent of it, like a equipment life, improving the system performance, and we can save our money and make more intelligence, and we can driving more data driven decisions. Okay. And then let's see, I think has anyone see predictive maintenance to like factories or lab settings, all these things. Okay. Let's imagine using ML optimized electricity in a college campus or manufacturing unit. Okay. I hope you guys are clear about it. And then let's discuss about the next topic. See AI applications across in the engineering fields. Let's see about the applications which we are using, like a fields in different fields. For example, civil engineering. Civil engineering means they are using a application, structural health monitoring, like a AI powered, like what we call the sensor detect the cracks or vibrations or structural weakness in real time. Okay, these are the civil engineer applications, optimizing the material uses like ML models recommend cost effective and sustainable material combination based on the performance the data. Okay, and then let's discuss about the smart city planning. Smart city planning means AI helps model traffic flow, energy consumption, waste management, and infrastructure development, all these things. For example, AI is used in earthquake prone areas to analyze building stress and alert the engineers before a collapse. Clear, because this AA is doing earthquake prone. If it happens, it will buildings and all are the collapse. But before one, it will analyze it. It will analyze and it will alert the people. Sorry, alert the engineers before it collapses. Okay. And then mechanical engineer. Let's discuss about the mechanical engineers. Predictive, the maintenance of it. Like a ML predicts the failures in engines, turbines, or pumps before they occur. Okay. And then robotic, because when on AI or ML, it should alert before that happens. That is the useful, that is the more used to for the people. Okay. And then robotic automation. Robotic automation means AI enables robotic arms to adapt to the improve during assembly or inspection task. Like advanced design optimization, AI driven CAD tools suggest a better shapes, like materials or mechanics for the parts based on the simulation. Okay. For example, say, as I have already told you that Tesla, and not only for the Tesla, BMW use a optimized car parts for weight and strength during the design stages. Okay. Every part for the weight or strength during the during the while designing the cars. Clear? And then let's discuss about the electrical engineering. Electrical engineering means smart grid optimization, means AI predicts energy usage and adjusts the grid to prevent overload. For example, power system control will be there. Power system control means AI algorithms maintain the voltage and frequency stability in our real time. Clear? And not only for that, electronic circuit design automation means like creating complex circuit layouts faster with fewer errors and all these things means all these like a companies like a Siemens use AI to manage the grid power like a loads during peak uses of hours. Okay. And coming to the ECE means electronics and communication engineers. How it means they most of the application they will use IoT device intelligence means AI process data from the smart sensors for a smart homes, factories, or vehicles. Like a advanced speech recognition means ECA engineers work on NLP and AI for accurate voice commands like a in our daily life, most of the use the Alexa, Siri, Google Assistants, all these things. These are the advanced speech recognitions. Clear? And then that is the not only thing, signal processing. Signal processing means AI analyzes AI, for example, enhances single clarity in mobile communication and radar systems. For example, AI is used in 5G technology to manage the bandwidth and signal quality based on the user location and their need. Okay, everything will be worked on the user needs related to that. Okay, and then coming to the biomedical technology, biomedical engineering. So mine means in diagnostics like analyzing X-rays, MRI scans, ECGs to detect abnormality means abnormalities faster than the humans. Okay, not only for that, not only X-rays, MRI scans, ECGs, it can discover the drugs also. For example, is more speed up the process for identifying the potential drug components like chemical interactions, all these things. Not only for that, personalized additions like AA tilers, traits like what we called AA tilers or treatments based on the patient's genetic data. Clear? And medical imaging analysis, deep learning models like detect tumors, clots, or fractures automatically from the scans. And not only for that example, Google's AI can detect debating retinopathy from the retina scans with high accuracy. And then let's discuss about the every engineering is enhancing speed, accuracy, decision making. It's not at all replacing the engineers. It is empowering that to make work smarter and data driven decisions. Because nowadays everybody thinking it is a replacing AI is replacing the engineers. It is not. It is empowering them to make more smarter than before. That's it. The way we are using is different. And let's discuss about the like See, for example, any branch people, any branch, for example, whatever, like a civil, ECE, triple E, whoever, they can be commended belong to the which branch he is. He can imagine how AI use casing helps to their subject, whether he is a ECE, triple E, civilian, biomedical, whatever. Okay, and then you can do the brainstorm for your application for your field. If you think, if for every in your, for example, in your branch, which branch you are, whatever, you whenever you think about your subject, there will be a AI will be there nowadays. Okay, but we should able to think like that, how it helps to our subject. And then let's discuss about the next one. That will be case studies, not factoring with computer vision. Let's see about it. What does it mean and how it is helpful to us? Means, see, traditionally we can call it as a like what we call the storytelling, like a storytelling, like a real world impactful. Let's say about it, and let's discuss about the how the smart manufacturing is the case study, how it is the from which domain it is from the. Okay, common challenge is the defect detection. Defect detection means it's a let's dive into the real world case studies, understand how AI is actually solving the problems like in different industries. Let's traditionally factors like a manual visual instructions to check the defects of the manufactured parts, where cracks or scratches or color differences or assembly issues, all these things. Okay, major issues will be the it is slow and it is inconsistent, depends on the human fatigue or attention. And then let's discuss about the most importantly, it's a prone error. Like humans might miss it tiny defects that can cause product failure later. Like how can AI help means AI with computer vision. We created an AI powered model that uses image classification like a to automatically detect or defects from the product images. Like using computer vision techniques, we train the model to like understand what a defective product likes like identify various kinds of defects like holes, misalignments, and dents, all these things. Like it flag any deviations in a real. Like it is similarly to how eye spots are something wrong. Like but here the AI does it faster and with consistency accuracy. Consistent accuracy it will give you when you are performing. So let's say about it, what are the tools we will be used for this and how it helps to the tools. For example, Python. Python is most present. We are using like what we call the Python is the backbone. We will call it as a backbone of the programming language for the AI because AI, data science people or machine learning people, most of them using the Python because it has a rich libraries are there and it is very easy to use with the person with a non-technical also. Okay, see, and let's discuss about the OpenCV. OpenCV means it is a open source configuration like that helps process and analyze the images like a CNN. CNN means convolutional neural network, means a deep learning model specially good at image recognition. Clear? CNNs means works by the learning visual patterns and edges of it and shapes, textures from thousands of images. For example, if I give the data with the like a folders like a cat images and dog images, it will predict like how many legs are there, how many and what is the shape of it, what is the texture of it, and what is the grids of it, and what we call the patterns, edges, everything it will like, and then it will give you the whenever you are giving new image to it, then it will predict what that is, what the image is. Okay, which category it is. And coming to the result, the outcome, the result will be the powerful because inspecting like saving human efforts, like accuracy improved by the 30% compared to the manual inspection. The company could have better quality control. For example, reduce the returns and warranty claims. And then let's discuss about the real time, real world contextual examples. Like one of the most famous use case of this. is in the automobile industry. Means already we have discussed about the Tesla, and not only the Tesla, Tesla and Toyota. These are the use similar systems to inspect the parts of the automatically in real time, like even in electronics and like detecting the scratches on phone screens or AI plays a, not only this, AI plays a huge role in this type of trends. Clear? And then let's discuss about the next slide. Means see tools and technologies. Tools and technologies means let's discuss about it. Whenever, for example, like tools and technologies, already we have discussed about the Python versions like R and the TensorFlow. These are the main programming language. Python is already we know this is the most popular language, and most of the people worldwide uses programming language is Python. Okay, and it will support with the most every AI library, and R is also excellent for statistical model and data visualization. For the person who are working with the data analyst, the people will use the more R. Okay, when compared to the data science or machine learning, or these people will work on the Python. So more common academia and research, it is used to like R is used to data heavy industries like a finance or bioinformatics. These are the. And then coming to the libraries. What are the libraries? Key libraries always we do know that TensorFlow, sklearn. TensorFlow means this is the deep learning framework. This is developed by the Google, as we already know, and this is the deep learning framework, and this has a lot of neural networks will be there. Like it is used for training neural networks and image speech recognition, and sklearn will be for the beginners. Like it is classic ML algorithms. It will work like a random forest. SVMs, linear regression, all in one library. Okay. And then coming to the OpenCV. OpenCV means computer vision. Then it will, how it works means computer vision will works for the facial recognition or facial detection or like image filtering or object tracking. Like in the manufacturing case study, we just see all those things. Okay, coming to the development of the platforms, Google Colab. This is a free cloud-based Python environment. No setup needed. You just open your browser and start coding it. Okay, plus you get access to GPUs for the fast training. MATLAB. MATLAB is a still popular in engineering circles for simulations and the control system. It also has a machine learning and deep learning toolboxes. These all are it. If you are familiar with all these things, you are great. You have already have a knowledge on it. And then let's see discuss about the let's discuss about the next time. Like I think we are covered with the tools and technologies, and we are done with this. And then let's discuss about the challenges and adoption because we are running out of the time. And let's see discuss about these and challenges in adoption means let's data quality and quantity. This is the most important thing. Like AI models are only as good as the data they are trained on. Like in engineering, cleaning label data can be hard to get, but whether it is a sensor logs, CAD data, or image captures, or bad data equals to bad prediction. Okay, so when we are giving the perfect data to learn the model, then you will get a better predictions and you will get a accurate predictions. Clear? Whatever we are giving, getting that better, that data or that output should be the more perfect. That should give you the more accurate. Then only we can use that model. Without that, how we can use it? And then not only that one, ethical concerns and bias. This is a especially important sectors like a civil, medical people or a transportation engineering. So like a bias in training data can lead a unsafe AI decisions. We also need to ensure AI systems are transparent or accountable. And not only for that, next one will be the skill gap. There is a shortage of AI talent, especially those who understand both engineering and machine learning. Upskilling teams and cross-functionality collaboration is a key. Clear? And then next one will be the infrastructure. Infrastructure and cost means running AI models. especially deep learning, can be computationally expensive. Not every company has the resources to set up GPUs, data pipelines, because not every company afford for it, because GPUs are not the easy thing. Whenever GPUs cost, that will cost, it will cost you more. It will cost the companies to more. The data pipeline, secure cloud system, all these things. Okay, because those are the expensive. So for that, platforms like a Google Colab help to bridges the gap for small scale or early stage projects. Okay. And then let's discuss about the wrap up messages. These challenges are the real but not insurmountable. Strategic planning, continuous learning, and ethical responsibilities, and will go a long way in making AI for effectively and responsibly in engineering. Okay. And then let's discuss about the next slide that will be commanded into the understanding convolutional neural networks. Already we know that we are discussed about it. Convolutional neural network is this is the CNN algorithm. It is a deep learning frame. It is the from the deep learning. So CNN means it will work for the image data. Like these deep learning architectures specially designed for the image recognition and classification. It means they automatically detect the patterns, shapes, textures in images, much like how context works for it. Next, CNNs matters in engineering, like one of the most impactful applications in automated defect detection. Like in manufacturing, CNNs can scan the high resolution images of circuit boards, welds, mechanical parts, and flags or anonymously faster and more accurate than a human eye. For example, let's say about the real-time example, a production like a robotic cameras, like what we call, can feed images into a CNN. It learns to detect cracks and scratches, misalignments, and even predict failures before they occur. Clear? And then let's discuss about the CNN use the layers called convolutional layers to extract the features, as we already learned, as we already discussed about the edges, corners, or textures. As we go deeper into the network, it recognizes the more complex patterns like the shapes and specific defects of it. Okay, so next one will be and then let's discuss about the YOLO speed meets accuracy in defect. Let's say about the YOLO means real-time detection. YOLO stands for out because it can detect multiple objects in a single pass, making it incredible fast. This is the perfect for a real-time applications like a tracking, moving parts, or identifying the defects on a fast moving, all these things. Okay. And manufacturing edge for you for what we call YOLOS is ability to spot defects instantly. Gives it you major advantages where speed is critical, even if it is sacrifice a bit of accuracy compared to the slower models. And let's discuss about the speed-based accuracy. While other models like a RCNN are known for the highest precision, like they took longer to process images, YOLO on the other hand is a balanced trade-off. Like you get high speed with reasonable accuracy or making it a favorite of manufacturing AI. These all the things. And then, like with the OLO, you do not have to choose between speed and intelligence. You get both, making it a go-to model for real-time quality control in engineering workflows. And let me know if you would like slide on like a if you want a RCNN with YOLO comparison, or let's discuss about the final conclusion. Okay, then let's move to the trusting AI explainability in industrial systems. And then let's discuss about it and this slide critical component of the AI in manufacturing, like a what we call the silencer maps, or we can call it as a line or sharp SHAP, like we will call it like this. Means saliency maps means these are the visual overlays that highlight the extra exact areas in an image. The AI model will focus on it. Like in manufacturing, this helps engineers Verify if the model is detecting the actual defect like the crack shown here, rather than being misled by shadows or irrelevant textures. While a saliency match works well for images, line and sham help explain non-visible features like a sensor data or production speed or environmental condition. They tell us which input variables were most influential in the AS decision. Context matters. Without explainability, you cannot ensure compliance like in safety critical environments. You lose the trust from the operators and you miss the chances to correct or improve the models. And let's discuss about that. And then coming to the next one, let's discuss about the digital twins in smart manufacturing. Like what we call, imagine having a real-time digital replica for every mission, every system, even entire factories. That's what digital twin offer. Visual models of physical assets constantly updated, like what we call the through live data and enhanced by AI. Applications across industries, aircraft engines, like a digital twins, predict engine failure before they happen, using real-time data to schedule maintenance and important monitor performance, like a schedule maintenance and monitor performance, all these things. Okay, like a smart business, they're optimizing lighting, heating, and power consumption in a real time, like driving energy efficiency and lowering the operational cost, all these things. And car manufacturing, so let's discuss about the automotive. For example, automotive means car manufacturing using digital twins to stimulate the performance, like under stress, reducing the design flames and minimizing the downtime during the production. Means key value. AI plus data is continuous optimizing the models. Don't just like means mirror data, like what we call the predicting it. For example, AI analyzes the sensors input to detect the anomalous simulate outcomes and recommend changes before the problem occurs. And then just give me a minute. Sorry for the disturbance. My laptop is going to be shut off. Then okay. Say let's say car manufacturer using digital twins to simulate the performance like a under stress reducing and design flaws or minimizing the downtime during production, all these things. And let's discuss about the next slide. Federating learning in model multifactorial training. And let's see about this. What does it mean and how does it works means federating learning enables means collaborating AI model like training across multiple manufacturing sites while preventing the data privacy and protecting and intellectually property. It offers a secure like a efficiency framework for building the robust global models like without centralized data sharing. Okay, local training means each factory trains its model, AI model on premises using local data. Means this approach leverages local insights while reducing the risk of data leakage. Clear? And coming to the model updates, let's say not raw data, instead of transferring sensitive data sets, only model updates like ingredients or weights are sent to the central server. This will minimizes the exposure and it will upload the data confidently. Okay, not only for that, we can do the data privacy and security. Means sensitive manufacturing data never leaves the factory premises. Means this ensures compliance with the data regulations, safeguards trade secrets. Okay. And then let's discuss about the global aggregation. Global aggregation means global aggregation is central several aggregates, model updates from all the factories. The global model is defined using the combined knowledge and redistributed for the local improvements. Clear? And then this is how it has. And then let's discuss about the next slide will be the AI powered robotics in some smart factories like a Let's see about it. AI drives advanced robotics like improving productivity, safety, and consistency across a modern manufacturing environments. Like a robotic arms automate the precision assembly, welding, and the component handling tasks. All these things. Autonomous mobile robots like navigating the shop floors independently to transport materials effectively. Not only for that, and then let's see collaborative robots. Collaborative robots means work safely alongside humans, handling the repetitive or strenuous tasks. Clear? And then let's discuss about the ethical and responsible AI in engineering. And then here we are discussing about that ethical and responsible AI engineering means it concerns bias in data, like ensure fairness and prevent skewed outcomes in defect the detection, and worker privacy, address the implications, surveillance, and data collection. Accountability means it will what we call define the clear responsibility for the AI driven decisions. And coming to the just best practices means diverse data set. Diverse data means use comprehensive representative training data to minimize the bias. Okay, and then let's discuss about the stakeholders. Stakeholder involvement means engaging the workers, engineers, and unions in AI planning and deployment. And then let's discuss about the audits and transparency and conduct. It will conduct in the regular reviews to ensure fairness, accuracy, and then explainability. All these things. Clear? And I hope you like this very much. And thank you so much for your being here. And if you have any doubts regarding this, and please let me know. Any doubts? Thank you for all your time and attention for me. AI is no longer just a concept of the future. It is a shape engineering today. Okay? From smart manufacturing to ethical decision and making. Let's continue to explore innovative. Clear? Thank you. I'm happy to take any questions or feedbacks from you. I'm ready to take. This is now that much clear. Okay.
தண்ணி அதிகமாயிடுச்சு, சப்புன்னு இருக்கு. தண்ணி கூட தனியா குடிச்சுக்கோ, நீ சாப்பிடு, இந்த தனியா சாப்பிடு. சேர்த்து சாப்பிட்டா தண்ணி இதுவா இருக்கா என்ன?
Kumar sir, could you please mute yourself?
அவ்வளவுதான்.
Sorry. Everyone, if you have any questions, please try to use the chat feature to post your questions. If you're unmuting, it could be a disturbance to others as well. Please try to post your queries in the chat so that both will be taking it up. Thank you.
Hi, good evening everyone. Thank you all for your active participation in day 2 of the Faculty Development Program. It was a pleasure having you with us for today's insightful session by Ms. Gopika. We look forward to seeing you again tomorrow for day 3, where we will dive into the exciting Internet of Things and robotics, led by Mr. Vijay Singh. Let's continue learning and growing together. See you in the next session. Bye. Thank you all. You can leave the session. Thank you. Bye-bye.